So last lesson for derivatives. You guys are going to write a quiz tomorrow on derivatives. So you're going to have to know, obviously, how to differentiate the different types of functions that we looked at. The first being just a polynomial function. Then we did the product law. Then we did the quotient law. Yesterday we did the chain law. When you have an expression raised to some power, an expression other than just x raised to a power, have to use a chain law for that. And today, implicit differentiation. So I talked a little bit about this yesterday. This is what we're going to use when we have an expression that has both x and y variables in it. So far, it's always just been y equals something, okay? Or f at x equals something. But we're going to see some expressions that have both x and y variables in some or all of the terms and how we differentiate that. And then, like I said, you guys will write a quiz tomorrow on derivatives, and then we will get into applications of derivatives. And then after that, we'll write our next test. So far we've only dealt with functions in which the dependent variable is isolated. So that means y, that's a dependent variable, and expressed explicitly in terms of the independent variable, which would be x. So that would be functions with forms y equals f at x. But what about something like x squared plus y squared equals 1? That's actually the equation of a circle centered at the origin with a radius of 1. We could solve this equation for y and then differentiate using the appropriate rule or rules. But what about a relationship such as xy to the fourth plus x squared y cubed minus the root of xy equals 1? So you cannot get y by itself for that expression. So for these types of relations, we use implicit differentiation. So step one, you've got your equation in terms of both x and y. Then what we do is we differentiate both sides of the equation, or essentially term by term, with respect to x. So that means when we differentiate any y term, we will use the chain rule. So the derivative of that term will end up with a factor of dy by dx. When you differentiate y with respect to x, to show that, you will write dy by dx. And then you're going to solve for dy by dx. So let's look at that first expression that we had at the top. If you want to differentiate x squared plus y squared equals 1. So that first term, the derivative of x squared is just 2x. So that is very straightforward. But when you differentiate the next term, you have to use the chain rule. So remember, the chain rule has two parts. The first part is you're going to take the derivative of that term, but then you're also going to multiply by the derivative of what's inside. And what's inside the bracket here would just be the base y. And so when you take the derivative of what's inside the bracket, that's our dy by dx. So again, chain rule has two parts. You're going to take the derivative of the term by using the power law. So the 2 comes in front of the y. The power is decreased by 1. But then you multiply also by the derivative of what's inside, which is the derivative of y with respect to x. That's dy by dx. And on the right side, the derivative of a constant is always 0. And then as it says, the last step is you're going to solve for dy by dx to get dy by dx by itself. So we would do that first by subtracting 2x from both sides. So it'll be negative 2x on the right side. And then we would divide both sides by the 2y. So dy by dx will equal negative 2x over 2y, or negative x over y. So there's an expression for the derivative. Okay? There's an expression for the derivative. Now, for question 2, we're going to differentiate each term. And what you have to realize here, in that first term, it is a product. There's 2 factors there. The first factor that you would differentiate would be the 3x squared. The second factor is y. So when you differentiate that term, you're going to have to use the product law as well as implicit differentiation when you differentiate the y factor. Same thing with the second term. That is a product. The first factor is x. The second factor is y squared. So when you differentiate that, again, you'd have to use the product law. And then when you differentiate the factor y squared, you would also use implicit differentiation now. So here we go. To factor that first term, again, product law. Derivative of the first factor, which is 3, times the second factor, which is just y, plus the derivative of the second factor. The derivative of y is dy by dx, times the first factor, which is 3x squared. So there's a derivative of 3x squared y using implicit differentiation and product law. Plus, now we're going to differentiate that second term. Again, that is a product. First factor is x, second factor is y squared. So using the product law, derivative of the first factor, which is 1, times the second factor of y squared, plus, when you differentiate the second factor, when you differentiate y squared, again, implicit differentiation is used. There are 2 steps there, because we're going to use the chain rule. The derivative of y squared would be 2y. That's the derivative of y squared using the power law. But then you also have to take the derivative of what's inside the bracket, which is just the letter y, and the derivative of that is dy by dx as well. So that's the derivative of the second factor times the first factor equals, on the right side, the derivative of 3x is just 3. So we can do a little bit of simplifying here, but the last step in this is also to isolate dy by dx. So let's start by simplifying some of these terms, and at the same time, we're going to keep all the terms with the dy by dx on the left. Let's move everything else over to the right. So you're going to have the 3x squared dy by dx, that's going to stay on the left, plus you've got 2y times dy by dx times x, or 2xy dy by dx, equals, so you've got the 3 on the right. We're going to move the 3y over by subtracting it, as well as the y squared. We'll move that over by subtracting it as well. Remember, we want to get dy by dx by itself, and we can do that by taking out a common factor of dy by dx on the left. So that'll leave us with 3x squared plus 2xy in the bracket. And then the last step is to divide both sides by what's inside the bracket. Okay, I've got something that I've got to fix here. Because when you take the derivative of 3x squared, I'm not sure why I wrote 3y. That should be 6x. I have no idea why I wrote 3y there. So it's the derivative of the first factor. The derivative of 3x squared would be 6xy. I have no idea where that came from. That should be 6xy. It's the derivative of 3x squared, which is 6x, times the second factor, which is y. So 6xy. So this will be minus 6xy, not minus 3y. Wherever I see this 3y, I have to replace that with 6xy. So I'm sorry, I don't know where that came from. That's better. And there are no common factors amongst all those terms, so you cannot simplify this anymore. There's x's in both terms on the bottom, but only one term on top has an x. Only 3 of the 5 terms have y's in them, so you can't do anything there either. So there's an expression for the derivative. Okay? And remember, one of the applications of this would be to find the slope of the tangent, so you'd use the derivative to do that at any point x. So looking at number 3, again, we've got 2 terms here that we're going to have to use implicit differentiation for because there are 2 terms that have y in it. Right? That second term, we'll also have to use the product law because it is a product. So step by step, derivative of x cubed will be 3x squared. For that second term, again, we use the product law. The derivative of the first factor will be positive 4x times the second factor of y cubed plus derivative of the second factor. We have to use the chain rule there. It'll be 3y squared times the derivative of y with respect to x, which is dy by dx, times the first factor of 2x squared. That next term, again, we have to use implicit differentiation, which has 2 parts. The first part is the power law, which will be 12y cubed. But then we also multiply by the derivative of y, derivative of what's inside the bracket, which again is dy by dx. And the right side is a constant. The derivative of that is 0. Is it this part right here you're looking at, Brighton? Okay, you have to use the product law there because there are 2 factors. The 2x squared is the first factor, the y cubed is the second factor. So you have to use the product law, which is the derivative of 2x squared, that's where the 4x comes from, times the second factor of y cubed, plus then the derivative of y cubed will be 3y squared dy by dx times the first factor, 2x squared. So again, we've got 2 terms that have dy by dx here, so we need to get those together, keep them on the left, everything else on the right, and we'll do some simplifying as well. So the first term with the dy by dx is the 3y squared dy by dx times 2x squared. That'll give us 6x squared y squared dy by dx plus 12y cubed dy by dx equals the 3x squared will move over by subtracting it from both sides. The 4xy cubed will also move over by subtracting it from both sides. Common factor of dy by dx on the left. Whoops, getting ahead of myself here. Gives us 6x squared y squared plus 12y cubed inside the brackets. And then we would divide both sides by what's inside the brackets to get dy by dx by itself. Right, so there's an expression for the derivative. And again, one of the applications of that is to find the slope of the tangent, and then you can find the equation of the tangent at any point x. In this case here, you want to find the equation of the tangent line to the curve 2x to the fifth plus x to the fourth y plus y to the fifth equals 36 at the point 1 comma 2. So we start by, again, taking the derivative so we can get the slope of the tangent. So the first term, the derivative will be 10x to the fourth. The second term, again, we need to use the product law there. The derivative of the first factor will be 4x cubed times the second factor, which is y, plus the derivative of the second factor, the derivative of y is dy by dx, times the first factor of x to the fourth, plus, when you differentiate y to the fifth, don't have to use a product law there because there's no product, but again, implicit differentiation to be used, which has two steps. The first step is using the power law. The second step is the derivative of what's inside the bracket. The derivative of y, again, is dy by dx. And on the right side, the derivative of a constant is 0. So we need to get dy by dx by itself. So all the terms involving dy by dx we'll keep on the left side. Everything else will go to the right side. Common factor on the left of dy by dx. And then we divide both sides by what's inside the bracket. So there's an expression for the derivative, and we can use that to find the slope of the tangent by letting x equal 1 and y equal 2. So that will be negative 10 take away 8 over 1 plus 2 to the fourth is 16 times 5 is 80. So it will be negative 18 over 81, which you can divide top and bottom there by 9 and get negative 2 over 9. So there's the slope of the tangent. And if we use point slope, we've done it this way. We've also done it using y equals mx plus b to find b. Again, the point of tangents use the point 1 comma 2, so it'll be y take away 2 equals negative 2/9 bracket x minus 1. If you multiply both sides by 9 to get rid of the denominator, we'll get 9y minus 18 equals negative 2 bracket x minus 1. So 9y take away 18 equals negative 2x plus 2. And general form, the x term is normally positive, so we'll take everything from the right, move it to the left. Positive 2xy, positive 9y. And when you subtract 2 from both sides, you'll get negative 20 on the left. So there's the equation in general or standard form. Oh, apologize, we do have one more lesson left. So that means our quiz will be not tomorrow, but Thursday.
Let's go. I love quiz days because you don't do any learning. Easy day.
Okay, so those are the questions you should work on. And we'll post the solutions to Google Classroom. Remember, you've got a couple assignments that need to be handed in from this chapter. So you need to get working on those if you don't have them handed in. And again, the quiz will be on Thursday.